Hello, my name is George C. Bradley, and today's presentation will be on how to conduct a binary logistic regression using SPSS. The overview, we have first data requirements that we'll go over the data set. Next we'll look at our hypotheses. That will entail research question and the null and alternate hypothesis. Next we'll go over the assumptions. There should be 5 assumptions, and we'll talk a little bit about that. And number 4, we'll have a demonstration on how to conduct a binary logistic regression using SPSS, and we'll finish with a write-up on our findings. Our data set online, HBS 500. We have 4 variables here. We have our outcome variable calculus, pass or fail. Independent variable trigonometry, pass or fail. The courses, gender, female, male. And we have a math achievement test. 3 independent variables and 1 dependent variable, and it's dichotic in nature. Binary logistic regression is the statistical technique used to predict the relationship between the dependent variable y and the independent variable x, where the dependent variable is binary in nature. We have 5 assumptions that we need to test before conducting a logistic regression. We need to test number 1, outliers. Number 2, observation to be independent of each other. Number 3, multicollinearity. Number 4, linearity of independent variables and log odds. Number 5, the proper sample size that we would need to have to conduct a logistical regression. I do have a video on testing assumptions for logistic regression using SPSS. Take a look at that on YouTube, and you can get more details on this slide. We have our research question. There is a statistically significant relationship between gender, trigonometry, math achievement test, and calculus. And as you can see, we have our null hypothesis and our alternate. Let's take a look here. Let's look at the demonstration using our data set right here. You can see right here, if you have your outcome variable, you have your calculus, you have your independent variable trigonometry, you have math achievement, and you have gender here. You can take a look at the actual data, write up data in another format. Okay, let's do our analysis. We'll go here, regression, binary logistic. For outcome, we're going to put calculus, dependent, independent, trigonometry, math achievement, agenda. As you can see, we have our 3 independent variables here in the covariance, and that's really where our predictors and independent variables would go. As you can see right here in categorical, if you had an independent variable that was categorical and it had more than 2 groups, you would place it here. But we don't have that here. Gender, sex is 2 groups, and trigonometry is 2 groups. Let's look at save. We'd love to save the probabilities and the group memberships. And this is one that we probably need to take just a quick look at. We probably won't look at it, but this is Cook's distance, and that would be for outliers. And right here, if this is above 1, then you need to look at that case. Let's take a look at options. We're in the classification plot. Hausman-Lehmann show goodness of fit. Talks about our model. And again, case-wise residual. This right here can assist us with outliers. We can click here on confidence intervals for our odds ratio. Okay. Now we have that information. We could go back here and take a look. We have 3 new columns. We have the predictors. We have the categories. And if I would do this right quick here, just to show you, we have one case that we need to assess for outliers, although we're not going to use it. Let's go back here and get this back where we started. And I can go here and let's look at our findings. Case processing summary. We have 50. Right here, dependent variable calculus, 0 for fail, 1 for pass. Right here, our classification table. As you can see, this is the intercept, this is the null, this is block 0. No independent variables here. Strong, you can see 91% without, and it's significant. But as you can see right here, you have no independent variables included. Let's go to our block 1. And block 1, let's see, let's go here. We can see right here that there is a significant, the chi-square, and the degree of freedom, and that was tested against the actual significant to show that it's significantly stronger than the actual null. And so this supports a strong model here, a good model. Okay, here are our pseudo R-squares. They're not the strength of the R-squares that we would find in a linear regression, but the Najar-Kirk is probably the one that we'll use because it has a 1 as the max. And this is, although it suits us, it would give us some semblance that about 58.4% of the independent variables are influencing the outcome variables. Okay, that's what how we would word that. All right. So that's the influence that the independent variables have on the outcome variable. But these are pseudo, and they're not exactly the same as what you would have in a multilinear regression R square. Okay, let's take a look at another table. We have a test here, another chi-square with Hosmer and Lima show test. And right here you have, there's no difference. It shows no difference in this test with the observed and the expected, and is not significant. So that supports a decent model. That shows that our model is good there through this test. Okay. Next table, classification table. And this is the classification table here, and you can see with the fail, it's very strong, 98%. With the pass, it's kind of weak. Overall, though, it's a nice model, 92.2%. So that's a good classification table. But you can see where it's weak, and you can see where it's actually very strong. Okay, let's take a look here. Let's take a look at our variables in the equation. Trigonometry, we have the math achievement, and we have right here the walls, the degree of freedoms. But what's important here is our sig. All of the variables are significant. And we have our odds ratio here. Our odds ratio. And you can see the one that we have here for trigonometry is almost 50. Okay, and then you have it for the math achievement is 1.3. And for gender, you have 2.3. I'm sorry, 1.4. More or less on 1.4 here. Okay, so we're going to look at how to write this information up. Now, before I move forward, we can take, I told you that we have some information on case-wise dealing with outliers. If you would look at these cases here, and you can see that we have about 4 cases that probably need to look at and make a decision whether to keep these or to take them out. And if you take them out, you'll need to run your analysis again. Okay. Let's take a look at our reporting, interpreting logistic regression results. A logistic regression was performed to ascertain whether gender, trigonometry, and math achievement tests could predict a college student's success in calculus class. The logistic regression model was statistically significant. You can see the chi-square, the degree of freedom, is 3, and the chi-square we have here is 153.875, and the probability is 0.001, which is less than 0.05, and 58.4% of the variance in calculus class is explained by the independent variables and correctly classified 92.2% of the cases. Successfully passing trigonometry gives a student 50 times more likely to pass calculus. Increasing scores in the math achievement test would increase the likelihood of passing calculus class, but males are 2.3 times more likely to passing calculus than females. So males are 2.3 more likely pass in calculus than females. Thank you. If you have any questions, please email me at georgecbradley59@gmail.com or send me a note through the YouTube channel. Thank you.